gentlemen, friends. This afternoon, I'm going to talk about advances in seismic design and construction in Indonesia. Indonesia is located in a highly active seismic region where several major tectonic plates collide. But unfortunately, in the past, the public awareness to seismic hazard and risk was a bit low until about a decade ago when the Great Aceh Earthquake struck with a magnitude of 9.1 and then followed by several other big earthquakes which also hit big cities like Yogyakarta and Padang. And it brought a lot of destruction, including some collapse to engineered structures, as what we see here in Jogja and also in Padang. This painful lesson has brought the attention to the government and the engineering society to the importance of seismic resistance design. So in the past few years, there has been several advances in the seismic design and construction for high-rise building in my country. Number one is the issuance of the new seismic resistance design code in 2012. Number two is the use of a more sophisticated method of analysis used in design office. And number three is the application of base isolation system for high-rise buildings. The 2002 code was written with the UBC 1997 as a reference. And now the new 2012 code follows the SCE 710. The 2002 code uses two-dimensional area source to develop the seismic hazard map with an equal hazard of 10% of probability of exceedance in 50 years, while the new one uses three-dimensional fault source with an equal risk of collapse of 1% in 50 years. Some seismic source used for the development of the seismic hazard map in 2002 has been exceeded in recent events, and that has been taken into account in developing the new seismic map. And also including some new active faults that has not been discovered in the old seismic map. And then this is the result of the about 2 years hard working of the team. And in this map, most of the places in Indonesia is having a higher spectral response acceleration than the 2002 code. And we have taken also almost all of the provisions from ASC 710 into our code, among others about the irregularities and the redundancy factors. With the advances in the many tall buildings in Jakarta, now there are a lot of buildings around 40 to 50, 60 stories being designed and built. Even a 2 mega tall structure is also being built, being designed in Jakarta. Then the use of the lateral system, which is in the prescriptive code, is starting to get not so effective. For this building, the Pakubono Signature, which is a 50-story building with 3 levels of subterranean structure, we use the PBSD method in accordance with the peer TBI. So we use a core wall with outrigger beams, 3-story deep, and for the gravity system, we use a flat slab system. As I've talked in detail about this 2 years ago, I will just touch briefly on this subject. We make a 3-dimensional nonlinear model, and for the core wall, we use the fiber model. Basement structure is included. SSI is not included, and model is fixed at the mat foundation level. And this shows you the structural response to one of the ground motions. And later, I will also show just some plots of the result of the nonlinear response history analysis. This slide shows the interstory drift in both directions. We have plotted all the result from each ground motions, and the interstory drift is well below the limit for the MC condition. And this shows you the coupling beam rotation on some selected components. Of course, we have to check all the components in the calculation. And this shows you the accumulated core shear in X and in the Y direction. The building has been completed in this year, and it's in use now. And then lastly, I'll talk about the use of seismic isolation system in Jakarta. After the painful lessons from several shakings, some of the rich clients started to demand higher performance for their building. And then it gave birth to the use of the base isolation system in Jakarta for high-rise building. We have to remember that earthquake can be very expensive. For example, in Kobe in 1995, it cost $7.5 billion US dollar per second. So the use of base isolation in Indonesia is following the ASCE 710 procedures, where the intent of the seismic isolation is not to reduce the cost of the superstructure, but rather to have a better performance. The fundamental principle is to modify the response of the building so that the ground can move below the buildings without transmitting this motion. And it's done by increasing both the flexibility and the damping. Some instrumentation in Japan showed that the ground shaking transmitted to the superstructure is only about 1/4 to 1/2 of the original ground motion. And this is the Gudang Garam office tower, 25-story, completed in 2013. It is the first base isolated high-rise building in Southeast Asia, designed by my firm. In this building, we use 40 bearings, high damping rubber bearings, diameter ranging from 1.3 meter to 1.5 meter. This slide shows you the plan of the base isolators. We put the isolators on the lowest floor. And this shows you the typical dynamic shear stress strain relationship for bearings. And we can see it has a very good characteristic, very good hysteresis loop. And most of the isolator is tested up to 300% shear strain without failure. For this structure, we use RC core wall and outrigger as the lateral resistance system, plus seismic steel moment frame at the perimeter. And for the gravity system, we use steel truss and composite metal deck and RC slab. And this shows you the location of the outrigger beam in the middle height of the building. And we have some shearling to act as a fuse to protect the outrigger columns. And in this slide, we can see that we have modified the dynamic characteristic of the fixed base structure from a fundamental period of 1.66 seconds to 4.3 seconds for the base isolated structure. And this shows you the performance of the seismically isolated structure compared to the conventional one. For the structure with the seismic isolation, we found that the interstory drift falls within the 0.2%, and it is always in the fully operational condition, while for the fixed base structure, it falls in the immediate occupancy category. But in my country, a good design will mean nothing without a strict supervision. So in this project, we put a lot of effort making sure that all the details are followed through. For example, the confinement of the rebar for the board pile, the diameter and the length of the hook for the stirrups, and other things. And lastly, we also made a final inspection to measure the temperature in the isolator, the dimension, vertical dimension in several points in the isolator. Also measure the gaps, because sometimes even though we have told our counterparts, the MNE and the architects, that the building will move during the seismic event, they still don't catch the meaning. They still put, for example, ducts in the gap. So we have to rectify that issues. And this shows you the completed building. Then the second building using the base isolation system is the 27-story Puri Matahari Tower. We use 38 numbers of high damping rubber bearings. Some is as big as diameter 1.6 meter, which I marked with a red dot there. And also we have modified the dynamic characteristic of the fixed base structure from the fundamental period of 1.9 seconds to 3.76 seconds. And we have about 21% effective damping for that building. And this shows you the outrigger locations, and the bending moment in the core wall is effectively reduced. So it can reduce also the tension at the corners of the core wall. And the authority has also asked us to do a nonlinear pushover analysis. So we compared both systems with the fixed and the isolated base. This shows you the result of the pushover analysis in the direction without the outriggers. For the fixed base, we can see that the first yield happened at around 13 meganewton, while for the isolated base, it's much higher at around 20 meganewton. And also, don't forget that actually the ground shaking for the isolated base is not 100% transmitted to the superstructure. So the performance is much higher than what has been shown in this pushover analysis. And then this shows you on the other direction, parallel to the outrigger plane. And for the isolated base, the behavior is more or less still linear until we have to stop the analysis. And then this also shows you that part of the interstory drift is from the displacement of the isolator itself. On one direction is about, say, in the low base shear, it's taken most of the displacement, but on the ultimate states, it's about 30%. On the other direction, parallel to the outriggers, it absorbs, the isolators absorb most of the displacement. And then this shows you the performance for the seismically isolated structure. It is always in the fully operational condition, while for the conventional structure, it is in the immediate occupancy category. The building is now under construction, and it is expected to be completed at about the third quarter of next year. And this shows you the work on progress, where the core wall, as is normal in my country, proceed a few stories ahead. Then we follow by the steel structure, and then put the metal decks and cast the concrete floor. So that's the end of my presentation. Thank you very much.